So here we are, 3.9. A is an alpha. Don't know if we'll need a second video, but let's put it on there anyway. I'm on page 299, and we're looking at the 4 basic graphs. Now, as time goes on, we'll get into some other graphs, but let's just stick with these 4 now. So let's go ahead and make this a little bigger so we can look at each one. All right, so the key thing to look at here is, remember we said that y is the same as f of x, the function of x. So these two are the same, and this is what we're looking at. If y equals x, it is going to give you a straight line. If the exponent on x is a 1, which it is because it doesn't show up here, so it's an assumed 1, it will always give you a straight line, and it will always go through the origin if it's just an x, or even if it's a number in front of the x, as long as a number isn't added or subtracted to the x. So as long as it's not something like that, it's going to be a straight line through the origin. And we'll add that 4 or add another number later if we have something like this parabolic. We have f of x, or y, equals x squared. When this exponent is a number other than 1, it will not make a straight line. It will always make some kind of a curve. So if this is a 3 or a 4 or a 5 or any number other than 1, it will make some kind of curvy line. Sometimes it'll make things like this, and just all kinds of weird curves. But that 2 means it makes a curve, and if it is a 2, it means it will make what is called a parabola, which either looks like that or like that, and it can be anywhere on the graph here, but it will look like that if it is a 2. All right, let's keep going here. If the x, the variable, is in the bottom, it will make 2 graphs, and they will be opposite each other like this. Okay, and then let's move on. If it is an absolute value, it will start at the origin and go to the left and go to the right, as long as there's no number added to it. As long as it's just the absolute value of x, it will do that. So that's on page 299, and just gives you an idea of what the graph will look like given the information they give you. So let's go ahead and see if we can get rid of that and go on with some other things here. All right, so I'm going to put a graph on here, and let's put it on here like that. And we had talked about the graph of a line, and I had said that if y equals, and it could be a number like 1/3 x, and there's nothing added or subtracted to it, it will always go through the origin. The angle might be different depending on what number this is. The number in front of the x designates what kind of slope it is. So we could have, a slope like that, or a slope like that, or a slope like that, but it will always go through the origin. If we add a number to this, so if we put a +4, it means that it will translate 4 units up. 1, 2, 3, 4. So it will be the exact same line, same angle, same slope, only it will go through 4 instead of 0, 0. So that will help you to determine whether it translates up or down. If this wasn't a 4, let's say it was a -6. Well, now it's going to translate down. 1, 2, 3, 4, 5, 6. So that will be a line that goes through -6. Same angle, it just will be translated vertically down. So that gives you an idea of what this looks like when you change the number that is added or subtracted to the x. Now again, it doesn't matter what number is in front of this x. It's still going to give me a straight line. This number here tells me the slope, the angle of the line. This number tells me whether the line shows up here or down here, or whether it goes through the origin. That's all this number does. Tells me where it crosses the y-axis. So that's vertical translation. So one of the things that they give us at the bottom of page 300 is a handy dandy rule. So let's make this a little bit smaller. And that rule is, if we have y equals fx plus k or fx minus k, that will give us our vertical translation. So this is what we just went over, but this is the general formula. If we have any x that has an exponent of 1, it can't have a 2 or 3 or a 4, and we add k to it, or we add a number to it, this means that it will go through a number up here, and this means the minus that it will be below the x-axis. So the f of x means it goes through here, and the k plus means it goes up here, and the minus goes down here. Now, if it has an exponent up here like a 2, it's going to also going to give you a graph. Let's say it gives you a graph like this. If it's a squared, it's going to give me a parabola. And then this k, so let's say that k is a 3. That means that it's going to move up 3. It's going to be the same exact shape. It's just going to move up 3. If it was, say, minus 3, it's going to be the exact same, only it's going to go through negative 3 here. Everything else is going to be the exact same as far as its width. It's just going to be translated down or moved down, depending on what that number is. Okay? So, for instance, if I had something like y equals the absolute value of x, which, if you remember when I can't get rid of that. When I showed this to you last time, or a little bit ago, we did this. Let me get my graph here. The absolute value of x might look like this. But if I add 3, that means it gets shifted up 3. Okay, that's all that 3 means. It looks like this, only it's moved 3 units. If I had something like y equals 2x plus 2, that means we graph the 2x like I have right here. And then, because of this 2 here, it shifts up 2. So now the actual graph of 2x plus 2 looks like that, like the black line, because this tells me the slope. This tells me how far above or below the origin that line goes. So it's going to get to a point where you can graph this black line here without having to, first of all, graph the blue line. So that's eventually where we're going to go, and you might already know how to do that. We've already talked about it when we did y equals mx plus b, where b is the y-intercept, where it crosses the y-axis. So it's already showing you that shift whenever you have a number there. So anyway, let's keep going. Part C on page 301 is called horizontal translations. So we will do a little bit on horizontal translations and then go to the second video. Now, sometimes you're going to have a graph that may look like this. Okay. The other graphs that we were doing that had vertical translations, or we shifted up or down, had a number or a letter plus a number. And it could have been 3x plus 2. Notice there are no parentheses, that this 2 is added to that. and that's a shift up or down. In what we have over here to the left, the x plus 2, the quantity squared, whoops, wrong button. The x plus 2 is in parentheses. So when it's in parentheses like that, we're looking at horizontal translations, left or right. So that's what we're going to look at now. If it is a plus number, and what they say is they call it the h. If it's a plus h, it will shift to the left. If it's a minus h, it will shift to the right. So let's go ahead and try one of these. Let's look at example number 3, and it's got an absolute value, and it says y equals the absolute value of x plus 3. So the graph of the absolute value of x is going to be something, it's going to look something like this. It's going to start at the origin and go left and right, 45-degree angles. This plus 3 means that the whole thing is going to shift 1, 2, 3. Did not shift up or down. It just shifted to the left 3. Okay? So even though you've got a plus sign here, and you would think it would shift this way, it doesn't. It shifts to the left. And later on in the course, we'll go through why that is, if you even care. But right now, just note that the plus 3 means, or the plus means you shift to the left. The minus means you shift to the right. Okay, let's look at example 4. Let me erase this and this. And let's go ahead and write what they have. Y, or f of x, equals the absolute value of x minus 3 plus 4. All right, so what I'm going to do is I'm going to do the absolute value of x without adding or subtracting anything. And it looks like that. That's the basic graph. Now let's subtract 3. So that means we're going to go over 1, 2, 3, and we're going to get this graph. Now we have a plus 4. What does that plus 4 mean? That's the up and down shift. So that means from here, we're going to go up 1, 2, 3, 4, and we're going to end up there. So once we shift our graph, our minus 3, and then up 4, it's going to look like this. So minus 3, which means we shift to the right, and plus 4 means we go up. And that tells me where my vertex is of this graph, and then I can just draw that right there. Right now, I'm not looking for perfection on your graph. I'm just looking at the shape being correct, as well as where the vertex is, so I know that you shifted it twice. You shifted it here, and you shifted it there. Okay? So that's the important thing I'm looking at. And it doesn't really matter which one you do first. You could have gone up 4 and over 3. Doesn't really matter, but usually you just kind of stick to the order that they give you there. Okay, so that's really all there is to the horizontal and the vertical shift. Now let's go to scale factors. Scale factors basically mean multiply. So pretty much just like if we have f of x equals x squared. Okay, right there, nothing's added or subtracted to it, and we know that our vertex is going to be there, and it's going to be a parabola that looks something like that. All right, let's say that we put a number in front of this. That is your scale factor. We have a scale factor of 2. That means that this parabola is being multiplied by 2. And what happens when you multiply is it changes the fatness or the thinness of the parabola. So when we have a scale factor of 2, it ends up making our parabola thinner. Okay, it seems like it would do the opposite, but that's not the case. If we made this number in front of x squared a number smaller than 1, it's going to make our parabola fatter. So if we make our this scale factor, this number is a fraction between 0 and 1, it's going to make our parabola fat. And if it's a number greater than 1, it's going to make it thin. Okay, something to remember there. All right, so let's go ahead and try one of the, oh, and one other thing before I forget. If the number in front is a negative number, doesn't matter if the number is bigger than 1 or smaller than 1, if it's a negative number, it flips the parabola upside down with the same point called the vertex, where it changes from going uphill to downhill. That point will be the same at the same place. All right, so that being the case, let's go ahead and look at an example here. And let's see, maybe I can move just this. Nope, I can't just move the graph. All right, looks like I'm going to have to get rid of all of this and bring in another picture. Try this again. Okay, so there's my graph. So let's say, for instance, that I have f of x equals 1/4 x plus 4, the quantity squared, plus 2. All right, so the base problem would be this. So that tells me that I've got this parabola that is going to look like this. We're going to follow, oh, that's an ugly one, but we're going to follow PEMDAS, and we're going to do what it says in the parentheses first. So in the parentheses, it says that we're going to translate this thing here, this parabola here, 4 units to the right or left. 1, 2, 3, 4. Same shape, exactly the same ugliness. We just moved it 4 to the left. Okay, step 3 says we're going to look at this. It's a number that's smaller than 1. So even though it doesn't seem so, it is going to make the parabola fatter. So it's going to be the same parabola where the vertex is. It's just going to be a fat boy there. Okay? So that's our 1/4, is it flattens it or makes it fatter. Next step is the plus 2. The plus 2 says that this guy's going to move up from where it is here, up 1, 2. So same fatness, just moved up. So that blue parabola right here, even though it's ugly and not exactly right because I'm terrible at drawing, it's going to move it right there, and that's it. Okay, so last one, and we will be done with this section. So let's see if we can do this last example. This is example 6. Okay, so there is our problem. We're going to switch this around because we want it in the order that we can work with. Whoops, minus 3, x minus 1, quantity squared plus 5. So all I did is move the 5 over. So negative 3. Okay, so that makes it easier to work with. So let's see what we've got here. So our original problem, in our blue, it should be, our original problem is x squared. So whatever our variable is and whatever exponent they give us, and it's going to be on the, through the origin there. Okay, so what's going to happen here? There is, first of all, there is a vertical expansion by 3. So it's going to change the size because of that 3. In fact, the vertical expansion is going to make it thinner because of the number that's greater than 1. And it is going to be reflected because it's negative. So this is going to be turned over. So it's going to be narrower and flipped over. And then it is going to move horizontally 1 unit to the right because of this negative. So it's going to move over here to the 1. And then this 5 here says that it's going to move up 5. All right, so let's do that one at a time, and then we'll be good. So first of all, we're going to do a vertical expansion by a factor of 3 and make it negative. So it's going to become thinner. Vertical expansion means that it is being basically stretched. So when things are stretched, they usually get thinner. So that's what happened there. All right, let's go to black. We're going to reflect it across the x-axis, which we did. We translated it 1 unit to the right. So I'm going to use black here. I'm going to use the exact same graph as the red one, only I moved it over 1 unit to the right because of that. And this says I'm going to move it up 5. So 1, 2, 3, 4, 5. And that's what I did. So the green one is our end result after we flipped it over, made it skinny, moved it 1 over to the right, and 5 units up. And that gave us our answer. So if we start with this, it's pretty easy because we just look at what's being done to the x squared. 1 is subtracted, -3 is multiplied, 5 is added. So we just follow the rules there and we're good to go. So that's it for 3.9b.